Hey,
Hello.
hey there.
Anthony.
Hey, Jordan. How's it going?
Pretty good. Was traveling yesterday, so I'm a little bit jet lagged, but only from New York, so I'm only 3 hours jet lagged.
Yeah, it's not too bad, but I feel you. I'm going to be driving out to Los Angeles today. So no time zone change, but 4 hour drive after. I've got a bunch of meetings this morning and then I'm driving out.
Oof.
I do it a lot. My girlfriend lives out there, so I end up going out there like every couple weeks. We go back and forth.
Right on.
So I'm used to the
Yeah.
drive.
Still doesn't make it particularly comfortable.
No, but I've just gotten really used to podcasts. I listen to a lot of podcasts, and it actually feels like a good use of the time. You know,
Like an
I've
audio book or something.
yeah, I've done some audiobooks. I've done some like political commentary and just philosophy and like current events stuff. But then I also have gotten obsessed with trivia. The last year, my friends have started going to bar trivia, and so now I listen to trivia podcasts in the car like all the time and just learn new trivia. All right. Adding myself to the agenda right now. I always forget to do that until the last minute. How's everyone else doing today?
Good.
Looks like we're still waiting for a lot of people.
It looks like Benji said he'll be back in a few minutes. And
Oh.
Lee is on the attendees list, but I don't see him yet.
Yeah, I haven't seen Lee in a while. He hasn't been in one of these.
I think if Lee's here, he's usually the moderator. He
Yeah.
actually marked himself as host, so I guess we wait for him for like maybe a little bit more, and if not, we find another person to be the host. Oh, Benji is here.
I thought it was going to be like, school if your teacher's more than 10 minutes late everyone gets to go home.
Oh, okay.
Ah, there's Benji.
Sorry about that, folks. Had to reboot.
No worries.
No Lee today, I guess.
I mean, he
Perhaps no.
signed up, but I don't know. Oh, he was here. Just joined.
Yeah, my computer
there he is. Yep.
muted, and that was really fun. As soon as I tried to open Zoom, the whole thing fell apart, crashed, which I haven't seen that in a while. Anyway, good to see everybody.
Good to see you too.
I might also have to move rooms. I'm in a corner of my office at the moment. I think someone's going to steal this room in a bit. So if I turn my camera off and disappear for a moment, that's why. But hello, everyone. Welcome to October primary working group meeting. It's good to see you all, and good to see some of you all again who we saw in person just not too long ago, which was a lot of fun. We have plenty of interesting stuff to talk about today. As we kick into that, let's have everyone reminder to everyone that we've got our spec membership agreement, participation guidelines, contribution guide, and conduct with sort of rules of engagement of this meeting. If you haven't taken a look at those recently, feel free to. Good content. And then, as is per tradition, a round of introductions in the room. And for anyone who is new, we usually do that by going through the order that is shown in the agenda doc, which I will drop a link in the Zoom chat just in case you don't have it. And if your name isn't there for whatever reason, just feel free to send a pull request and we'll get it added. And my name is at the top, so welcome everybody. My name is Lee.
I don't see Robert here, so I'm going to go ahead and say that I am Jordan and I work at Meta on Relay.
Hey everyone, I'm Calvin. I work at Apollo on the iOS client.
Hey everyone, I'm Ernie. I work at Coinbase.
Did Benji already go?
Sorry, I was looking at the notes. It's not set up yet. Hey everyone, I'm Benji.
I'm Alex. Here's an independent.
Martin, working at Apollo on Apollo Kotlin.
I am Benoit, also working at Apollo on the Kotlin SDK.
Hi, I'm Rob from First Dibs.
And
And I'm Kuwait from Meta. Sorry, I just added myself last minute.
Thank you. Did we miss anybody else?
Oh,
Steve?
yeah.
I'm Steven. I work in Netflix.
Yep. And hi, I'm Anthony. I work at Apollo on the iOS client. I also just added myself. I don't think it's been merged in yet. So
Awesome. Thank you all. As we get going, I will pop open the pull requests to make sure everybody who's here and has a pull request open is added into the meeting. Thank you for doing that. Benji, as per usual, is in our notes doc and building out some stuff. But if I could ask other volunteers to make sure that they're looking as well, especially as Benji jumps into the discussion to take over note taking. I'm seeing some head nods, so I'll take that as a sign that we've got some other folks in the notes doc. Thank you. Okay, quick overview of our agenda. We will take a look back. I don't know that we actually have anything worth talking about from the previous meetings, but I'll take a quick look. Reviewing some action items if we happen to have any. And then the two major topics for today are client-controlled nullability and full schemas. Is there anything else we want to have on our agenda today that is not already listed in the doc? I'm hearing silence, so we'll take that as we've got the right stuff to talk about. We did not end up using our secondary meetings last month, so nothing real to update from either of those. And I think we have 2 aging action items, one of which is a meta action item, which is a clearing out of the old action items. Thank you, Benji, for doing some cleanup. And also one of which is another old action item, but I think that one says ready to review. We'll take a quick look at both of those.
So the meta cleanup one, I suggest that I just go through and just close a bunch of the old items. We've raised it in a few working groups recently. If your item hasn't been commented on in like the last 6 months, I think we should just go ahead and close it, and I'll take care of that.
That sounds right to me. We should probably have like some kind of base rule for like keeping action items fresh. 6 months sounds like a reasonable baseline place to start. That falls below the garbage collection phase. Okay, that one sounds great to me. Any other concerns with that? Excellent. We will call that one decided. We will be garbage collecting. Oh, Yvonne, I see you joined. Welcome, welcome. You want to do a quick intro?
Hi, my name is Ivan. I'm from Opova and I'm from my phone. So I will be, most of the time I will be with disable video and muted.
Glad to see you. Glad to have you here. Okay, the other is we have an action item open, Benji. That is also sort of an aging one about clarification of selection sets. And you're saying we're resolving this by creating open tickets on the spec. Is that right?
Sorry, I'm just loading it. Which one? What's the number?
Sorry, let me look at the number. This is 1335.
Yeah, got it. Yeah, so this hasn't been actioned for a while, and I've basically put forward that there's 2 ways of solving this. Either we just close it, or we close the pull request, I think, or I've also proposed an alternative pull request. I think that the pull request that was raised, number 984 in the spec, I don't think that is the right thing to do. So I think we should close that. We've left it open for a long time, but I think this one actually should be closed because it's not the right solution.
Okay. The one you link to is just one that is, it looks like it's fixing a bug where the
no, so it's talking about executing a selection set serially. So that's why it looks like fixing a bug. But it's talking specifically about a selection set rather than an operation. And this is effectively what Roman argued is, well, it's an operation, but the text of the spec here talks about actually what is executing a selection set serially. So if we were, for example, to expand serial execution of selection sets to happen at different positions in GraphQL, which has been mooted a few times, for example, having like serial types was mentioned at one point, then I think this would not want to have the mutation keyword.
But the lack of the mutation keyword implies that this is a query, not a mutation.
That's effectively what Roman says, yeah. But what it's actually talking about, right, is a selection set. This isn't a full operation. This is just a selection set. It's a subsection of an operation.
that's subtle in a way that might be confusing, right? Like the text above those examples says when executing a mutation, the selections in the selection set. I mean, the implied statement there is the selections in the topmost selection set of the mutation. So like the example, it's weird that the example, like I think I'm confused as to why his proposed change is the wrong change. That
if we change it to do this, which would also be fine, then we should also change the wording in line 399 so that it says, for example, given the following operations. Because the example there wouldn't be a selection set, it would be an operation.
I think that's right. The intent of the example was to show a full operation. Like the example is a document. The example is not like a sliced out part of the AST, like redrawn. And I think that's the reason why it was perceived as confusing. And I'm interpreting Roman's suggested change there as a correct but not complete change.
Okay.
If that makes sense, right? It's like the example should in fact imply that it is a mutation and it was a mistake to have not had the mutation keyword there. And what you're saying is also true, which is the wording above it is not quite correct, that we are describing the below as a selection set when what we should really be describing the below as a operation with a selections in its top level selection set. So we can decide like how pedantically correct we want that paragraph to be, whatever will end up being most descriptive.
All right, well, let's leave it open for now then, and see if we can follow up with a fix to the wording around those changes.
Cool. That sounds like the right next thing, and I am comfortable with that being a set of incremental changes. If we want to say like, yep, Roman found an incorrect thing, but he just only partly fixed it, we can like probably take the partial fix into the draft and then add on top of it resolution to the above. But I don't feel strongly about that. So it's just an option for us to keep things moving in closed PRs.
Yep, sounds good. I am still not 100% convinced that this is the right solution though, because we are talking about execute selection set. So having the example of a full operation makes sense, but also we are specifically talking about executing a selection set. So it feels slightly...
it's definitely incomplete. So yeah, I agree with your uneasiness. Okay, we know our next step on that one. Thank you for flagging it as needing action. That's the one that we won't garbage collect.
Okay, cool.
Okay, good little micro topic there. Thanks everyone for sitting along for the action items. On to our first big topic, client controlled nullability. Jordan and Benji, the floor is yours.
Awesome. So yeah, my plan here is to sort of outline some ideas that I shared in a post about 3 weeks ago, along with how it interacts with client controlled nullability, and then also some sort of gaps in the spec that were additional things we would need in the spec in order to support it. And then Benji will have some time to share some ideas of how we might go about making those required changes, if that's the direction we wanted to go. So to start out with, I just want to start with like a problem statement, which both this true nullability idea and client controlled nullability are trying to wrestle with. And it's just the ergonomic challenges of managing the pervasive nullability in a sort of well-formed schema according to our best practices document. The practical reality of writing code against a fully nullable schema is pretty uncomfortable. And so we've sort of long sought some kind of way to at least mitigate that challenge. And what we've seen is that, you know, as it stands, product code will do a lot of, you know, null coalescing and other kinds of tricks to make do. And then eventually also there are places where it can't, and it will do something destructive and make some kind of assertion and say, like, look, there's nothing sensible I can do here. And both client-controlled nullability and a feature in Relay called @required sort of give a declarative syntax to this part of the problems, to this solution, in order to make it a little bit more convenient. But there's a fundamental problem with both of those solutions, which is that they're making these destructive assertions blindly, in that they can't see through the schema whether a field is expected to be null at some point due to in sort of the normal operating function of that schema execution, or whether it is an exceptional case that that field would be null and it would always be associated with an error. And I want to step back and think about, and this is sort of my reverse engineered justification for why the world is the way it is today. So feel free, anyone who has more context here, to disagree. But my sense is that this all comes back to sort of our approach here of conflating null and error and coercing errors to null. And so I want to say first, like, why do we do that? What is the rationale behind it? And the rationale is that we want the server to be able to, or the client and server relationship, to preserve an agreement that the data portion of the GraphQL response is type safe with regard to the schema. And so you can always just take the data portion of your response and assuming that you have knowledge of the schema and the expected types therein, you can operate on it with an expectation about which fields will be there and which fields will not. And what this means is that when a field is in an error state, we have to find some type safe way to put that in the data. And that's sort of where we get error coercion, right? We can say, okay, well, we'll write it as null. And then we have a problem of fields that can't be nullable. Well, what do we do in that case? Well, there's really nothing we can do locally on that field. And so we end up with error bubbling as like a secondary solution to the problem introduced by the null coercion of errors. But again, all of this is in service of being able to make this assertion that the data portion alone must be type safe with regard to the schema. And as we worked on adding more explicit error handling to Relay, we started to see the world a little bit differently, and to start to see the response not as a type safe data and then some sort of optional nice to have, like, oh, it's some debug data in the errors array. Isn't that cute? But rather as an encoding of a single tree where any node in the tree can be in one of three states, sort of like it can be a null, it can be a value, or it can be an error. And the fact that the errors stuff is at the bottom is really more of like an encoding decision in order to preserve some like namespace within the data area so that we don't have any confusion about what's error and what's not. So that's like sort of my view of the world, but maybe I'll pause for a second just to get, like, I've seen some nods, but just does this pass the vibe check? Does this seem more or less a correct read of the world?
It is. I'll add one other thing that I think is an important frame to this problem, which matters mostly on the like schema definition piece of the problem, which is sort of forwards compatibility. And how do you design a schema such that future changes that you may or may not anticipate can be made in a way that does not break older clients? So thinking about, like, how do you make decisions that are in the future will allow you to make non-breaking changes. And an important one is the sort of general case is you can always, from a given field, you can always return a subset of the values for a particular type, but you can never send new kinds of values that did not align to that type, because a historical client will then be surprised by that. So a classic example of this is you have a field that's returning a dog, and you can't later say, oh, whoops, it turns out we made an assumption that people can only ever have dogs as pets, and what we actually meant was pet, because now all of your clients that are like dogs go wolf, but pets don't go wolf, and they like, they crash. And nullability is exactly that shape of problem. It's just sometimes warped into a different shape. Like it is a unioning of two types. There's like the thing that you can get, and then there's this other kind of thing called a null. And then a nullable thing is the like union of those two types. And so another part of the sort of historical thing here is this, okay, why does GraphQL do nullable by default with a modifier to non-null, which is weird. Why does it not do the thing that most programming languages do, which is non-nullable by default with a modifier to include null? And the answer is, had we made it non-nullable by default with a modifier to add nullability, that modifier is never safe to add to an existing field. You can never say, here's a field that's returning you a dog. Just kidding, in the future, now it's a dog or a null, because all the previous clients that assumed that null wasn't possible will NPE. But the opposite is safe, to say, this is either a dog or it's a null, and in the future say like, actually, null can never happen here, so we will clarify, is in fact always a dog and exclusively a dog and never a null. That is safe. And so adding the nullable or the non-nullable modifier in the future is a safe thing to do for any field. And that is important because typically when people are designing schemas, they don't think too hard about what modifiers that they're adding, and they often do whatever the paved path looks like. And so the schema design allows you to pave path into the thing that may have some like client-side pain, and this is the trade-off that we should be discussing. But the value is the like preservation of being able to add and amend it in the future. So that is not a statement of my opinion, but that is a statement of like the historical reason why we ended up in the state that we're in.
Do we have anyone else? Cool. I will continue. But yeah, with more time for questions later too, and additional comments. So we now have this sort of understanding of why we have this error coercion to null. And now I want to sort of introduce an idea or like a label of error handling clients. So these are clients who are uncomfortable with this coercion and say, look, the two things are not necessarily safe to me, or I'm not comfortable rendering partial data. And you have either a more sensitive situation, or you have some other kind of a rationale for that belief. And this was our motivating factor to look at explicit error handling in Relay. We're looking at adding Relay to the Ads Manager product at Facebook, at Meta, and we sort of have an additional degree of sensitivity about correctness, and the sort of the coercion story is less, people are less comfortable with it. And we're not alone. There are lots of clients who make this, who say, look, I don't ever want to see null just because it's an error. I only ever want to see null when it's really truly null. And this includes something as simple as, a fetch call in JavaScript followed by, if there are errors and the length is greater than 0, throw away this response. And in fact, my understanding from talking with some folks at Apollo is that this is the default behavior in some Apollo clients today. That by default, they say, look, we're just going to give you all or nothing. Either it's fully correct and not partial data, or it's in an error state, and that you sort of have to manually opt in to say, look, I'm okay with partial data. So there's a class here of non-resilient error handling clients. And what we're looking at and that I think is important, right? It's a pretty big compromise. GraphQL has a really important story around being able to present this resiliency. which is like a competitive advantage when talking to people and how they think about the value of GraphQL. And then we're sort of throwing that away when we have these simple error handling clients. And so what we were doing in Relay is looking at, well, can we sort of have our cake and eat it too? Can we be an error handling client that will never show you a null that is actually an error, but actually contain that in some other way? And so I think the mental model here that has been useful to me is, if you imagine reading a field on the client is actually more similar to like lazily evaluating the resolver on the server, and that might throw. And so what you do with this approach is you're sort of like mapping the error that happens on the server and propagating it all the way through to the very last moment when you actually read it. Now in Relay, that happens at like at a fragment read granularity, but you could also imagine other languages that have like a strong result semantic, or that have other kinds of error handling mechanisms. And so again, this is another type of error handling client that is going to say, look, you're only ever going to see null if it's a true null and not if it's an error null. And so if you think about this class of clients, like they're doing a whole ton of work to handle a bunch of nulls that in reality are never going to be null. And like, we could be telling them that, right? If the return type of the resolver method on the server is non-nullable, the only time they're ever going to encounter a null is if that value is, if there is an error. And so I guess setting aside, we'll get to later Lee's point about forward compatibility. And so it would be very nice if we could have some way to communicate to those clients, the true nullability of those fields. And if we could do that, they could safely present to their product code these types that represent the true nullability of the actual server resolvers. They could still handle errors in a resilient way. And the process of writing client code, product code, would become dramatically simpler, in that they wouldn't have to contend with this pervasive nullability. And what's more, when they do encounter a null value in their types, they would actually know that this is not a type which I can sort of destructively deal with, because it's only going to happen in exceptional cases. They would know, oh my gosh, like I shouldn't put an @required directive here. I shouldn't use a client controlled nullability bang here, because like the server says this is a normal part of operating of the operating world, and I can make a much more intentional decision about this is a condition I must handle. Which I think actually does get to Lee's point, which is we can tell a story about forward compatibility, but it's a little bit ivory tower, because in practice, and I think @required and client controlled nullability both sort of point to this, product code is taking, to some degree, an assertion-based approach to dealing with these nulls. And so while from a type perspective, yes, okay, it's safe to make this change, in practice, can you actually do that without breaking your clients? Maybe not. So there are really two pieces that are like missing from GraphQL as a specification to enable something like this. And one of them is some mechanism by which, especially, and this is about like, not necessarily about a like brand new world, but about getting to this world from the world we live in today, which is some mechanism for error handling clients to see the true nullability of the schema, while still allowing existing non-error handling clients to see the world, an execution model that maps, and expectations that matches what they expect today. So you imagine an error handling client and a non-error handling client living side by side, sharing the same server, sharing the same schema, potentially. How do they both get to see the nullability that they should expect? And Benji has a sort of draft of an RFC to share around that. And the other one is that error handling clients, especially resilient error handling clients, like Relay is on a path toward being, would like to opt out of null bubbling because it's not necessary. And in fact, I think the more I think about it, I think what they actually want to opt out of is error coercion generally. I think the bubbling is actually downstream of that initial point. And so there are certain clients now who say, it's actually fine with me if you give me any garbage at any location, as long as that is masked by an error metadata pointing to that field, telling me that I shouldn't use that data. And if we can opt out of that null coercion, then actually the null bubbling goes away on its own. You would never encounter that. That's my take as of like 2 hours ago on a walk. So I guess I will pause there for just like questions or comments on that. And then we can also maybe get to then have some time for Benji to share some ideas about how we might solve those at the spec level.
This might be a question that is premature, that we'll get to Benji's piece later. But I'm curious why we don't have all the metadata we need today to do the thing that you described, to like accept any amount of garbage as long as the like error information is there, because we do have the errors sidecar data, which I agree with your framing it's essentially an encoding of saying that like there are errors that exist within the payload, and then a client should be able to figure out how to use them appropriately. Do we need to articulate a type, or like can we already intuit from the outcome that a null here means, or that the errors alongside of it means that that thing is in fact an error, not a null?
Yes, so the client can know that. The challenge is how at sort of type generation time, if you have a field today which is null only as a precaution in order to provide an error boundary, that then error handling client would like to provide its product code with a non-nullable type that it doesn't need to null check. Maybe I'm misunderstanding the question.
Oh, I see. The difference being not about how you interpret the payload, but the difference being like how you represent the actual like source of truth type in the schema.
Exactly right.
Okay.
Stephen?
An example might be like if you were doing code gen into a language that has like a concrete result type and an option type, like Russ say. In most cases today, you would technically probably be saying a result of an option of T, because something could be null, but also could be an error, and you don't necessarily know which. But if you know that certain fields are really not nullable but errorable, then you can have like a a result of T for all of those, and you don't have to deal with the case where this might be not an error, but there's intentionally sometimes null is a value for this.
That makes sense. I'll also add a little non sequitur, because Jordan, you mentioned something that resonated, and there's like a historical source of validation of what you said, of the like ivory toweriness of like the nullability backwards breaking changey thing, and like clients actually doing the right thing with that. A classic failure mode here that happened early on was like before client-side type generation got good, and before we had much better type-safe languages like Swift and Kotlin on mobile clients. We had Objective-C and Java generating mediocre-looking types and not thinking too hard about nulls, and Java clients in particular, classically not being very good at null management, and who were, of course, assuming all over the place that nulls weren't possible. And 99.9% of the time, they were in fact correct until a server had a bad day, in which case all the clients would NPE anyway. And so all of the like thinking about how to manage the nulls ended up dying on arrival. So that literally happened to like early Facebook mobile codes, and we had to course correct for it. So validation of that point, non sequitur.
I will go to Benji. And I guess there's one other piece which I don't have sort of in my outline here, which I don't know if it feels important to get to today, but is arriving at some kind of consensus around how we want to think about this idea and how it relates to our work on client controlled nullability. I think, yeah, and so we've had some discussion in the last CCN working group. I know we didn't have a catch up on that in our agenda today, but that might be worth touching on as well. But maybe we can go with Benji's topics, and then if there's time, get to that.
Okay, thank you, Jordan. Great overview. And obviously the client controlled nullability thing has been something we've been thinking about for quite a while now, a good couple of years now that we've been experimenting with the various syntaxes. And one of the things that keeps happening is we keep trying to simplify it, but then different people want different things from it. For example, some people want this kind of throw mechanism, whereas other people just want the standard null handling that you have in GraphQL normally. So it was kind of trying to figure this out. And that's when Jordan came along with his, well, really what we want to know is what is the true nullability of this field. And that actually does seem right. It doesn't eliminate every single use case for the client controlled nullability, like exclamation point and question mark, but at least it diminishes them by like 80 or 90%. And suddenly there is a lot less value in those. And now it's better handling them in the clients, for example, using like a TypeScript exclamation mark or whatever. So the way that I see this is that effectively we kind of have two extremes at the moment. We've got the nullable, which is the default, and we've got the non-nullable and never an error, which is the right-hand side. So the nullable can be an error, can be where an error is caught, and the non-null would never be null. And what we need is this thing in the middle that says that it will never be null unless there's an error. So that is literally what I've proposed. I'm going to attempt to share my screen. Presumably this one. Okay, so what I have done here, hopefully you can see the null only on error type asterisk. Is that correct? Not from anyone. Yeah, great. So what this RSC follows another RSC that I filed the other day but have since closed. What this effectively suggests is that we have this new type. So this would be a new sort of sibling. It's a wrapper type, so it would be similar to the list type and the non-null type, and it would be called null only on error, or some other name that we come up with that can be workshopped later. So effectively, it's an alternative to not null, and it operates in some cases like not null, and in some cases like nullable. So it very much walks the line between those. Just like for the non-null type, why are you not expanding GitHub? Just like for the non-null type, where you would have an exclamation mark, here you've got an asterisk. Again, symbol is not necessarily important. It could be an ampersand or an @ symbol or whatever we want. Not an @ symbol. But anyway, and effectively non-null and null only on error are mutually exclusive. So a thing can be wrapped in one or the other, but not both. And I've written up effectively a truth table of what that would look like. So you can see that in basically all cases, an error will never be thrown. It will always coerce to null, and the error will be logged as if the field were a nullable field. The only case where an error is actually thrown at this point is where there is actually a non-null here, which I've shown how that interacts. So I'll let you look through that in your own time. Now, the really important bit here is what Jordan mentioned before, which is the need for these error handling clients and these non-error handling clients to be able to work with the same schema. Otherwise, we have to start maintaining two schemas or something like that. Things get really complicated. And what I did is I took inspiration from the include deprecated that we already have to say you opt into having those deprecated fields. And I've done the same thing so that a field you opt into including the null only on error wrappers. If you don't opt into that, then all you're going to see are the regular types, the list types, and the non-null types. You won't see the null only on error types. And as far as an old client is concerned, a field that can be null on error is equivalent to a field that can be null or null on error. So old clients will be effectively unaffected by this, but we can now give tools the ability to indicate the true nullability of this. By giving this middle state as well, this asterisk, it also means we've got this new symbol, but we're not breaking the meaning of either of the old symbols, which I think was quite critical because we don't want to change the interpretation of any SDL or anything like that. And broadly, this just leverages the existing behavior of the GraphQL spec with a few modifications, a few very subtle things. Yeah, so even when we come down to the null I can't expand it. This is the null handling section of the spec. The text on that is actually unchanged because the text in it actually says, if it is a non-null type, then it needs to propagate. And we don't have a non-null type in a null only on error. So therefore it does not propagate. Now I need to try and find the stop sharing button. There we go. So I guess this is the initial proposal. Lee, sorry, you were going to say something.
Sorry, I cut you off. Thought you were wrapping. I guess my first question is, why is this? What's the new semantic information that is being communicated by a schema developer? Or rather, like, is this being introduced as a separate thing purely as a mechanism to navigate like how we would introduce this in a way to minimize breaking things? Or like, is there a world in which someone creates a brand new server from day one, has like no worries about breaking existing things because they're building something new, and they are simultaneously making semantic choices about when to use non-null versus semantic choices about when to use null unless on error? And as a client-side developer, does this combination of the use of the two seem great, or does this seem frustrating?
Yeah, I think I'll interject, Benji. You can also answer, but I think my sense is absolutely this is really only about needing to have a bridge from the current world to the new world, and I think part of that is understanding how valuable like the current world is, because we're sort of carving out like the people who want null error coercion to null is actually like a pretty narrow band in this sort of hypothetical future of clients who can do resilient error handling on the client. So like a resilient error handling client wouldn't like that, wouldn't want that behavior. Just a brute force error handling client that doesn't care either way. And so that leaves like sort of a set of simpler clients, which I think we absolutely care a lot about, that also need to preserve some kind of robustness, and also are not concerned about the conflation of nulls and errors. Like that's like, the Venn diagram intersection of all those conditions does leave some clients which may potentially still want the old behavior. But
like, would one client prefer this? This is why my question is about semantic definition. Because if it is, if what we're saying is this introduces a new kind of semantic, then that implies that there's like a super advanced team using the best possible tools. They're using the latest possible version of Relay. They're using an awesome server that supports all this stuff. And they're like, I have a reason why I'm using non-null here and a reason why I'm using null unless error here. And there's important reasons why my Relay client needs to interpret between the two. Or is that like not a scenario that should ever happen? And in fact, you're like, nope, we're just in the, you never ever use non-null in your schema. You just only ever use null if on error, because like that's the new preferred way to build things.
Yeah, I think if you don't care about that like intersection I described earlier, if that is not an important client for you, then you wouldn't need all three different modes. However, if you do care about such a client, or you anticipate in the future wanting to care about such a client, then I think the semantic difference is meaningful. Or in the practical sense, if you have one of those clients today, which you probably do, because that's how they all work today.
The migration. Well, that's because part of the reason I was asking is like, if it is in fact introducing a semantic, then like, I really like this proposal because it allows us to describe both. But like, then I would have questions. Like, I don't actually understand semantic clear enough myself. But we could get that with examples and descriptions. But if it's less about semantics and more about introducing a new kind of behavior that's preferable for an advanced client, then I can imagine a competing proposal, which perhaps you already considered and ruled out, is a flag that you pass along with an operation to be executed that says, please don't null bubble. Like when something says non-null, what I would like for you to do, server, is to take the non-nulls, put errors in the payloads, and like I know how to interpret that as a error that occurred at that location, as opposed to a null that blew up the payload.
That's also what I would actually prefer, because then like the consumer is in control of that.
Yeah, so I think as Benji's about to demonstrate, you actually, I think we actually need both. Yeah.
So the second part of this is the ability for a client to opt out of null bubbling, which we have proposed before, for example, Stephen's talk with the no bubbles please directive or something like that. But yes, I think that these are two concretely separate things. I think they're maybe related, but effectively the previous RFC is about talking about the difference between this is always going to be a string, this is a string or an error, or this is a string, an error, or null. And I think that is an important differentiation. At the moment, schema designers shouldn't really mark a field non-nullable that might throw an error, because that is then going to blow up the next level. And that isn't really desired. We know that that's going to cause issues, for example, for relay writing that data to a normalized store in the case of an error and things like that. There's all sorts of issues. So effectively, when you have a nullable field, you're saying this could be null, or it could be an error, or it could be the thing that you've asked for. When you have non-null, what you're effectively saying is, this is definitely going to be the thing that I'm telling you, and I would not ever expect it to error. That's what you're saying. And what we need is this middle ground. And I think that this is not just a requirement, unlike what Jordan says, for specifically error handling clients. I think it is a useful thing to know, which is this isn't expected to be null. It will only be null if something goes wrong. You know, if I fail to get this from the related service. I think it's in the future situation, you wouldn't end up only using nullable and null only on error, because you still, I think, would want non-null for things like the ID field on a node. That should never, ever be null, and it shouldn't ever have an error there. If it's got an error there, then the entire node is invalid. So the explosion of that makes sense. Jordan.
I guess I maybe think about it a little differently in that I think in practice, any field can error, right? Like we would like to maybe some provably correct language could say this thing will never error, but in practice, any field can error. And the question is how we deal with that. And if you have an option like the second RFC that you raised around opting out of that null coercion, then in practice, like there's no way to avoid the potential that thing might be in an error state. And so I could imagine a world where you do say, like, the only two valid symbols in the new world are the asterisk and the no annotation at all, because we're never going to see, or I guess you can slice it either way, because the semantic gets confusing when you have this additional opting out of null bubbling or error coercion flag. But I think maybe it's actually more beneficial to say, in a no error bubbling world, you have to admit that any field can be in an error state. And so the only distinction is to whether you expect it to be null or not, or nullable or not.
That resonates with
also,
me, and that aligns the original frame of why everything is nullable by default. And not that everything could semantically include the value null, but that anything could an error. And similarly to this idea of making sure future changes are possible, is this idea of like, you start small, you build like a monolith, small, prototype client or server that has all your data in it, and then your business grows, and then you're like, okay, this subset of this model, which previously we had made the assumption is just coming straight out of a database row and can never be missing, is getting factored into its own service. And that service can absolutely go down. So now all of a sudden, these things that historically could never throw an error and was safe to call bang instead of asterisk, that's not safe anymore, because we've factored it out into its own service, and like, whoops, now we got to change our schema to represent that, or otherwise we've missed the opportunity to describe it appropriately. So it's like another flavor of this being, making sure that there's future evolution paths for the schema as your technical infrastructure evolves.
Yeah, but like this new asterisk state, it would have no value. Like, if anything can fail, like why should we put this? Like, what is the benefit for me as a consumer? I don't get like where this could be beneficial for me as a consumer, that I can put now here and okay, I expect this to fail. But like typically when you have something like this, there should also be, okay, I expect this to fail and it could have this error, something like this. But in the sense of the schema, for me, it's more about that the client can switch null bubbling off to do that itself, or do some isolation work or fragments and stuff like that.
Turning null bubbling off doesn't fix one of the issues for the client though, right? Because you're still, if that is all you have, then by default in your schemas, you're still going to want to mark your fields as being nullable, because they need to be able to handle this error state. So that means that every client still has to handle this situation where every single field that they access by default is going to be nullable, and they have to handle the null case for it. What do I do if the ID is null? What do I do if the username is null? And that is exhausting. And it's one of the main reasons that the client-controlled nullability with the bang in the query came about, so that the client could say, look, if this is going to be null, then just blow everything up, because I don't care anymore. I can't be bothered to handle this. But the asterisk gives us the ability to actually indicate that it will only be null in an exceptional case. So now, so long as you've got an error handling client, like Relay might become, you can know that this thing is going to be a string. And if it turns out to not be a string, be a null or an error in this case, then that error will be thrown. And you can catch it then at, for example, a React error boundary. So then that error is limited in your client to where you read the thing, and not to the entire selection set that is done on that field, for example. Alex.
But isn't it a problem, the actual problem that we have, that if you have two fragments in one selection set, and now one of the fragments brings in a non-nullable field, and that leads to also erasing my other fragment data. So the key issue is more about that you want to isolate the fragment data and kind of catch these errors on a fragment level, and that you could do when you disable the non-null propagation. But like for me is like any field could throw an error. And there is like, what is the benefit of having this asterisk there? like I get that true nullability gives me now the ability in the client to apply the standard algorithms now per fragment, so isolated. But the asterisk, what does it give me? Like what is the decision I should do with that in a client?
So the distinction is, so you're absolutely right that disabling null bubbling is the thing that gives you the ability to do all that stuff on the client. And I think the need for this third state is really only about being able to bridge between existing clients who have one set of expectations and new sort of clients who are going to disable null bubbling, who will have a different set of expectations, and most critically not at runtime but at type gen time. That the existing clients will want to render these middle, like Benji's described these three states, right, of like null or error, non-nullable, and null only on error, and never error, always, and never null. Like that middle state is the one that would be interpreted differently by code gen for an existing client and code gen for a new client. And that's why we need this additional ability for clients. I think about for the clients to be able to see through the schema into the actual resolvers implementation, whereas the existing and legacy clients would prefer to see the potential for how it's going to be handled by the server and how null bubbling will be affected.
Feel free to take it.
I don't know who was next.
Martin.
There's a lot here, but if we're talking cogen and the asterisk proposal, like something we did not mention yet is at catch directive, which is from what I would expect was the thing that was going to actually control the cogen. Like from a client point of view, if asterisks become the default, because we're saying probably should, like a lot of fields should become asterisks. I don't want cogen to generate a specific like result type or union type for each asterisk field. I want the union only for like specific places where the client is prepared to handle the error, because this is the main issue from the beginning is we don't want, I'm working on the client side, I don't want to handle errors on each and every field. I want to control where the error is happening and where I want to handle it, and other parts I'm like, well, never mind, I'm just going to throw away the whole response. So yeah, back to my initial, there were a lot of questions in the chat, which is why I raised my hand and then we switched to cogen. But back to the initial point, I think the new in the middle type with asterisks shouldn't be concerned too much with cogen, or do you see a way somewhere in relay that cogen is involved there?
So the distinction is, if I am an error handling client and a field is in this middle state, I can safely say to my product code, my product engineers, this field will never be null for you, because I will take on responsibility of handling that error some other way. Maybe that's throwing away the whole response. Maybe that's throwing at the fragment boundary. Maybe that's letting you opt into more specific handling within that catch directive. But I can now safely give you a non-nullable type and say, you will never encounter a null here because I will shield you from it. However, an existing legacy client cannot make that assertion because it's not an error handling client. So it would need to generate a nullable type, excuse me. So a legacy client would type gen nullable, but an error handling client, be that one as simple as fetch and then throw if there are errors, would be able to generate a non-nullable type.
Yes, okay.
Lee? I think you're muted.
Oh, shoot. Thank you. Thanks for the discussion. It's clarifying in my mind why these things are necessary. And I like in the chat, there's this back and forth between Martin and myself that was helpful. I had a similar thought that Martin just shared, which was what do we want the default to be? And I remember with seeing various people go through the motions of figuring out how to use the non-null modifier, like the part of the thought of non-null modifier has this effect that we've described a couple of times in this conversation as being like a very meaningful effect, in that it creates a different way in which errors bubble that can be quite destructive. And so some schema builders will put the asterisk, or sorry, the exclamation point everywhere, and then they'll encounter an error and it will create a huge problem for them. Oh, am I gonna get kicked out of this room too? Sorry, I'm like bouncing around between rooms today. I'll keep talking. And so I'm wondering, once we introduce asterisks, does that end up becoming the thing that you want to put everywhere? Or is that the thing that you use sparingly, in the same way that we are advising that you use the exclamation point sparingly? Because if we anticipate that a sophisticated service with a sophisticated client will say, actually, you know what? Almost every single field we have does not semantically include null. There are a handful of exceptions that do absolutely include null, but the vast majority of them only really will include null in the scenario that it's an error. Then you're going to start encountering services that just like have that asterisk everywhere, and it's going to make it challenging to first to like, what the heck is that asterisk? How do I interpret it? There's like an understandability problem, as well as just like a proliferation. And now as a schema designer, needing to like be very aware that you need to do that. So an alt proposal, which you may have already considered and ruled out, in which case I'd love to learn why, introducing first a question mark operator that says this field is a nullable field, which imbues the semantic knowledge that that thing is in fact either that value or it is null, and interpreting the absence of that as the ambiguously null. And that is in fact like a kind of a true statement historically, which is it can be null, and the reason why it's null is ambiguous. Sometimes it's because it's only in the case of error. Sometimes it's the case that that was in fact a nullable field that just never came with the appropriate modifier. And the question mark makes it explicit that is in fact intentionally semantically nullable. And then in addition to this, because I think it's not enough, because you also want the behavior that you're describing, Jordan, is something that is a flag on the schema as a whole that resolves the ambiguity. The absence of that flag, which is what the state is today, is it's ambiguous. That is in fact today's default case. But with the introduction of the flag, you can say, if you encounter a field that does not have either an exclamation point or a question mark on it, it can still return you null, but it'll only do that in the case of an error. It is never going to be semantically null. If it is semantically null, we will tell you with the use of a question mark operator. And then that allows sort of like a migration path where services can begin by starting to modify with the question mark operator, telling various client teams about like how to interpret that and like what the actual, how to, judge the ambiguity in the meantime, and then like later flipping on that flag once they're confident that all of them are in the right places.
So I don't think this will surprise you at all, Lee, that this is exactly where I started. I was like, in this ideal world, what we want is a question mark over here and a bang over here, and then the middle point. But of course, as you mentioned, the problem is that now we have the blank means nullable, and now we would be saying that actually the question mark means nullable and the blank means something different. It means only null on error. And so I even thought like, oh, we could add an indication on the schema keyword to say that you're opting into this new behavior. I didn't come up with a good actual, like I was thinking a directive on the schema keyword or something like that, but I didn't think of a good one. That would get rid of the fact that we can omit the schema keyword, because you would actually have to now always have that. I considered we could indicate it in some other way, but we don't have a good one at the moment other than directives really. But whatever, that's by the by. The main issue that I thought that this would cause is just the fact that like every single SDL that currently exists for people that are building schemas, for example, SDL first, and they've got like their user type in this file and this and this. If they want to introduce this, suddenly all of those files need to be all modified, and everywhere that doesn't currently have a question mark needs to be given a question mark. And then they need to go through and think, oh, which ones of these am I removing? Which I think is a huge lift. So like if it was GraphQL 2.0, I'd be like, yeah, this is what we should do. It should definitely be the question mark. The reason that the asterisk is there is effectively, well, also, I think you still can't go from an asterisk to no, you still can't go from that middle point to a question mark as a non-breaking change. Like the question mark in your proposal, which is the current nullable state, is the base. Adding an asterisk or adding an exclamation point is a change that you can't come back from. But the new point would be the question mark. Removing it, you wouldn't be able to come back from. I think so.
This, I have to like, I don't know, if you have an examples file or something, I'd love to see it. Because I'm trying to think through how moderately sophisticated or unsophisticated clients interpret this. Because in a world in which you're saying, or in today's world, the unadorned field says this is ambiguously null. It might null because null is the appropriate value. It might null because there is an error. The way in which you as a client should interpret the is observing the errors sidecar and seeing if there is in fact an error that lines up with this particular field. That would still be true. Like if you add all the question mark modifier or asterisk modifier is doing is indicating a constraint on those sets of scenarios. And the nice thing with the question mark operator is it's sort of telling you like you won't have to worry about the subset. And then the only new behavior once the schema flips on the, hey, the ambiguous thing, I'm telling you now that ambiguous thing does in fact will only be on error. The non-sidecard payload, the data field in the payload will be identical. So if you're a client that exclusively consumes the data field and just ignores the error sidecar, no change has occurred whatsoever, which is the vast, vast majority of clients. And the new thing that will change in the errors payload is you'll see a new entry into the error that says, this was a field that was not supposed to be null, that was null. It's a non-nullable, this is a field that was not intended to receive null. It did in fact receive a null, which is the same one that we emit for non-null modified fields, except those bubbles. So like you get that error and then, the null propagates somewhere else and you have to track it. But in this case, it would just, the data payload would be equivalent. So, and this is why it gets back to my, the prompt into whether this is interesting to explore or not is what is the default? Because I can imagine also it feeling like a huge lift to appropriately annotate all of the asterisks across your code base. But anyway, I'll pause there. But I want to explore this further to like what the change cost is, because if that's where you started too, then there's something there. Like, can we figure out what variant of that actually allows us to have a migratable path into it that allows us with like the shape of the schema design tools that we want? I hope that it's there.
Yeah, I mean, like if we, step back and look at this from, our backend developer who knows nothing about GraphQL and is, coming to GraphQL, and you see like this SDL, the asterisks are going to be confusing, or I mean, any other symbol we come up with, question mark would be more intuitive, and also, as we said, this would be, make the default. The most prevalent case would be nothing, and so it's just going to be objective or planar. And so I think we all agree there. I think it's just a matter of, is this actually something we can do without breaking a GraphQL 2.0? And despite how fun it would be to introduce some terraforming, it's really tempting. But and so I think it is worth starting from this, the thing that we think would be cleaner and better, and just then what we're now kind of iterating towards is how can we make this something that can be a smooth migration that's not going to be breaking. And I think the key there is really it's in the the whether or not we're returning errors, because it's true. A lot of clients dump the whole response if there's an error. So if our server suddenly starts inserting much more errors, that's probably gonna break prod. In most cases. But there's that's where we have options. As we said, something a flag on the server or from the client maybe, because it might be like your older clients, you don't want to start sending them errors, but your newer clients, those are the ones that it's okay to insert these errors. But maybe from the spec standpoint, it can be even a bit agnostic to that. It can say that the default now is that unless marked with a question mark, this is in error. This null is the result of an error, and if that doesn't necessarily mean there has to be an actual error message in the array. It's still we know it is something that is determinable, that this was an error, and our metrics can reflect that in the client and in the server, and then clients can have the the flexibility to to handle that, even if there's that not actually an error message there, because you think about the server behavior would basically be either the resolver has an express error, or the server is the framework is just inserting this generic error message, and it's just stuffing that over the wire. Maybe that doesn't add a lot of value anyways. So that's just kind of an alternative way, is to just not enforce the server has to actually insert error.
That's super interesting. Okay, I'm going to move us on because I do want to hear about full schemas, and we are running short of the asked 15 minutes for that. But thank you all for the progress on this. I think we have a much, much clearer sense of the problem domain and how we want to solve it than we ever have. Thank you in particular to Jordan for going deep on this one. And I think we have some direction for how to take this. Appreciate it. All right, Martin, on to you.
Thank you so much. Yeah, it's actually a similar or related topic somewhat, like it's all linked. We discussed full schemas last time, and for a bit of refresher, the idea is in Apollo Kotlin, we need a way to validate an operation, and we can do that completely exactly without knowing what kind of server we are talking to. Like, for example, we need the directive definition, or like the typical example is the include deprecated on input values that was added recently in introspection. Someone may add it to an operation. And if we don't know what server we are talking to, then we need this kind of information. So this work came through that point, that idea that it would be interesting to have an artifact, a schema, maybe certainly in the GraphQL language, because this is what people like to use, because it's really readable. And take that artifact, take an operation, take both of them, and be able to validate. And I'm saying this is somewhat related to the previous discussion, because this kind of implies that both the client and the server kind of share the same static artifact, which is a representation, certainly using the GraphQL language, of the full schema. So full schema being what's introduced here. We discussed a lot about introspection last time, but for this presentation, I went with something a lot simpler, which is just adding two new root rules in the grammar, in the GraphQL grammar, in the specification. I didn't find any other naming that source schema document and full schema document name can be, of course, discussed. A source schema document is what we mostly use today if you are doing a schema first implementation. This is what you use. You write your types. You like it because it's small. It's written by humans. So we avoid repetition. And by that, you don't have to type your schema definition, for an example. And obviously, you don't type the built-in types because it's boring. And also because it might conflict with the implementations that's going to read your source schema. So a source schema can be as short as this one here, a small schema, very nice, very concise. But then when you want to validate, so on the other end of the equation, when you're in Apollo Kotlin and you want to validate a full operation, including maybe introspection queries or whatnot, we need exhaustivity. And so the full schema document would be defined as something that contains all the built-in types and doesn't have to be in the specification itself, doesn't have to be defined, but the use case would be primarily that it's written by machines. And so it's a lot more verbose, like it would include always this schema definition, which we mentioned earlier, which then becomes a way for tools to know if we support this new null bubbling opting out or this new blank paradigm. So this contains everything, with a few exceptions, which I'm going to talk about later. It contains also the introspection type definitions, so it can be quite long, but the idea is that you're not typing it, the implementation generates it for you, either through introspection or maybe some other way, to give a schema to your front-end developers. By omitting introspection, and I hinted at that before, like there is one thing that's missing from the full schema, it's the meta fields, which we discussed last time. So __ schema, __ type, and __ type name. Mainly because, well, type name is very verbose, and if you want to read a document with a lot of type name everywhere, it's not super fun. And also, this also means because there is no schema inside there is no __ schema inside the full schema, it means you have type definition, like for all the introspection types that are not going to be used. And I understand this is something that we try to avoid. But the interest of that, like the good part of that, is that we don't have to solve every problem of feature detection or like how to do metadata in introspection or anything like this. We can actually add it with a few additions to the grammar and to the spec. And this is actually, I feel this is taking taking care or taking into account use cases that exist today. So today, a lot of users of Apollo Kotlin, what they do is they do an introspection query, but because they don't want to check that in source control, they convert it to GraphQL before checking in source control. So they have already kind of full schemas. So the proposal here is just to make it official in the spec and improve the language around what can and cannot be, like the starting point of that. And maybe I should have led it with that is in the spec, there is written very clearly right now that you cannot have any scalar definition, for an example, like this must not be in SDL anywhere. And well, this is what this proposal is trying to tackle. I think that's it. Yeah, that was my only slide. There's also there's a spec edit which I added last minute to the agenda. I can maybe go quickly if we have a few minutes. So this was the initial like starting point. So kind of funny. It was adding 4 lines, and yeah, it's turning into something much bigger now. If we go the latest, yeah. So that's the latest spec edit proposal. And if we go to the changelog, yeah, it's adding, basically the gist of it is this. There's a bit more below, which I'm not going to go into. But yes, that's it. That's all I have today. if we have no question, we can finish 5 minutes late or go back to the Asterix discussion.
Yeah, Martin, I wanted to ask you, like, what do you view as sort of the stage of this? What shape of feedback would you like?
I don't know, any objection? If there's no objection, let's merge it. I don't know, there's something else, like from immediate feedback, I guess, is there's also a pull request on built-in types, adding an appendix in the specification that defines what the built-in types are. So I'd like to merge this one. I feel like this is useful. Stuff that's shouldn't have, I mean, I feel it's mostly definition or terminology, like it shouldn't bring too many discussions. So this one, and what else? There's also a pull request on terminology in the glossary. So in the working group, we have this very nice glossary that I think Benji started some time ago, and I would really like us to find some common terminology to know what we are talking about. Maybe it's more actionable than a spec edit because we cannot really merge edit to the specs lightly. We'd have to really think this through. But I feel we can iterate more on the glossary. So if people could take a look at these 2 pull requests, which I can link, then I'd be super grateful.
Since we're running short on time, probably the right next thing is for you to have a discussion topic for folks to weigh in async with thoughts and feedback. I think my general sense is how much of this needs to be in the spec because it is changing the way in which GraphQL operates, and how much of this is like ecosystem effect. And I'm not sure. So I think that's an interesting thing to poke at. But thanks for the presentation. Appreciate it.
Do you think it should be a discussion, or like can we do this on the PR directly?
It's up to you. Whatever works best for you. I think both of those can be quite effective.
Sounds good.
Alex, you're asking a good wrap-up question on next action items. Sorry for not making that specifically clear. I think the next action items is probably we now have like a handful of floating proposals, and I think either we need to pull them together into one. There's sort of a like, can you take each of these in isolation from one another, or is it actually the case that you need an entire suite of changes in order for this to be an effective holistic change? That's like a thing to figure out. And then the other is there's I think a very specific critique on the asterisk indicator being potentially confusing because people have preconceived notions of what that symbol means in other languages. And this question of if this is the right additive change to GraphQL, then what's the right way to describe it? Or, going back to the sort of like question mark style frame there, have we like fully disproved that direction if that was the original preferred path? And so there's probably more exploration to do on that front.
Just checkingly, with the question mark, do you see that as being effectively the same proposal? It's just we're moving where we're putting the symbol. Like the actual behavior is the same, essentially.
I think that's probably right. But of course, the devil's in the details, especially with regards to backwards compatibility and the ways in which, like if there's real observed differences and we think that's going to have like a negative ecosystem effect, we should weigh that very, very heavily. And there may be variants there which resolve that ecosystem effect if we can figure out how to do it thoughtfully. And you even figured out one of the ways in which we could do that for this net additive change of like in the introspection query adding, you need to opt in to receiving that information. So I assume that there's something, the shape of it might put a bad taste in our mouth, but like we should still explore the space of like what would it look like to introduce the thing that we think is easier to explain to the world, but is harder to manifest, and like why is it manifested? And then I agree with Michael's comment here that having the null bubbling per query switch thing figured out is like a worthwhile thing to continue to apply pressure to. That's our time, folks. I appreciate the in-depth conversation. That was a lot of fun, and we made some progress. Appreciate it. And we'll see you all next one. Thanks, everybody.
Thanks, everyone.
Cheers.